I'm going to stand behind here because I've got some notes. I'm not actually talking about rabbits. I'm talking about disease of rabbits and how effective that's been in recovering small mammal communities in the arid zone. Rhys Pedler and I work for the South Australian Arid Lands NRM regions for JUNA in a small scientific services team which provides ecological advice and scientific guidance for our regional operations. Firstly, I'd like to thank Rhys for compiling the manuscript and our collaborators for contributing significant data sets and providing critical input throughout. We have compiled evidence from existing studies to link to the decline of rabbits following RHDV. I won't even try and use a pointer because I'm sure I'll stuff it up. Australia has the worst mammal extinctions, as you probably all know, for the world, and particularly in small mammals in the critical weight range of 50 grams to 500 grams, and it's probably even worse for South Australia's arid zone. Losses have been attributed to combined effects of habitat modification through European land use practices and introduced herbivores such as rabbits, plus predation pressure from foxes and cats. RHDV, or rabbit Haemorrhagic Disease Virus, was introduced into Australia after it escaped from a trial site on Wardang Island in October 1995. It spread across the continent even faster than the rabbits did. Economically, it was estimated to have benefited agriculture immensely, but the environmental benefits are impossible to quantify. Some work has focused, we get there, 350 million. Some work has focused on short-term changes following RHDV, including prey switching and recruitment of long-lived plants. However, little work has been done on the long-term ecosystem changes. Over the last 2 decades, we've got some evidence from New South Wales media about unusual small mammal finds for mammals that have been extinct within that state, coming back in 2003, 2008, 2011, and I can tell you that it's still ongoing with plains mice turning up at Fowler's Gap in March 2016. Fowler's Gap's a research property that has been heavily or well trapped for small mammals over many decades. And also in WA, the desert mouse has recently been confirmed to have moved 300 kilometres range extension to the southwest, and that was reported in Australian Mammalogy just this month. The small mammal data has been sourced from government and privately funded surveys and monitoring programs, plus incidental species records lodged with the Australian Museums. This data is accessible through the Biological Survey databases of South Australia, the Atlas of Living Australia, as well as published and non-published state, government, mining company and non-government agency reports. The authors have also been involved in the design, data collection and publication of results for many of these studies, which include exploratory general biological surveys, targeted threatened species surveys and monitoring programs, land management experiments and mining impact assessments. Small mammal distributional changes were examined using standard methods with the IUCN criteria. Extent of occurrence was mapped for each species in each period pre and post RHDV using minimum convex polygons, and area of occupancy was calculated using the number of 10 by 10 kilometre grid squares in which verified records were recorded during each time period. A 615,000 square kilometre area in the arid northeast of South Australia was used to look at changes to the distribution and abundance of a range of small mammal species for which we had good data. 3 of these had most of their post-1950 records in this region of South Australia, allowing us to interpret the changes in distribution with confidence. Rabbit, cat and fox population pre and post RHDV were examined using long-term monitoring data sets from Site 3 on that map, which data from 1991 onwards, and Site 1, Roxby Downs, from 1989 onwards. This area is arid, 100 to 200 millimetre rainfall, and is subject to stochastic changes with unpredictable rainfall. Major landforms include stony plains, dune field, deserts, low ranges, an extensive floodplain, ephemeral swamps and river systems, with most of the small mammals we've chosen are sand dune and stony plain sort of specialists. Those are the beasts. So we looked at a wide range of small native mammals and chose these 4 species because of the data coverage that we had for them from targeted surveys, and also they turned up at some of those long-term monitoring sites. All have appeared to have suffered major contractions in distribution and abundance since European arrival, with 3 having been listed as threatened under state and federal legislation. 3 are rodents, with the mostly under 50 grams, with the plains mouth being close to 50 grams, and the 4th is a carnivorous marsupial, the crest-tailed mulgara, which at around 100 grams is in the critical weight range for Australian mammal extinctions. This slide highlights the changes in extent of occurrence for these species pre and post RHDV. Notomes alexis is the most widespread species occurring across West Australia's sandy desert country and southern Northern Territory, with the study area representing the southeastern edge of its continental range. Its expansion southeast is most significant, as there are no subfossil records that we know of in the Flinders Ranges, to which it's sort of moving now. Its increase we measured at 64% increase in extent of occurrence. Subfossil owl pellet analyses and historic records tell us that Notomes fuscus suffered severe range contraction prior to 1970. The post-RHDV range expansion has reclaimed some of their former territory at about 364% increase in extent of occurrence. Pseudomys australis has similarly reclaimed former territory, including large areas to the southeast of its known range, with 241% increase in extent of occurrence. Whilst the Dasycercus christicorda showed the greatest recovery, reclaiming its type locality with 9,000% increase in extent of occurrence. And I must add that some of this, because we weren't actually surveying for this project, I guess there's data gaps, so that's probably an overestimate. I'm sure they would have been out in the Simpson there, but people just didn't record them. The 1996 to 2009 dark blue polygons highlight this recovery, particularly as that happened during a below average 15-year span, indicating that in this period rainfall was not the important driver of the observed response. This slide shows the rainfall at 3 weather stations closest to the long-term study sites. It highlights the 25-year pre-RHDV period, that first sort of more than half of the graphs, which were well above average, and that the post-RHDV period, that 15-year period immediately after the virus went through, was when most recovery occurred, and it was below average rainfall. We split that last 5 years, 2010 onwards, because there was a substantial period of high rainfall over 2 years, which mimicked some of that high rainfall that happened during the 70s, and we did get it was a driver of extra population expansion and dispersal for all 4 species, some of which have moved into sort of habitats they don't normally use. This slide here shows that The survey efforts were reasonably even in terms of number of sites surveyed pre and post, and that's partly because of the longer time frame earlier, and the number of targeted surveys we did post. So we did quite a few general surveys pre-1995, and post-1995 they were more species-specific because we were following up on stuff that we learnt in the general surveys. Plus there's a whole load of other people out there working in the later years for mining companies and things. The long-term trap sites include over those from 89 onwards that there was regular standardised trapping at those 3 sites. It was different in each of those, but it was consistent within the site, and they were designed to pick up small mammals. We were also extremely lucky to have access to long-term data sets from those monitoring sites. So BHP at Site 1 was collecting info on rabbits, foxes and cats, and likewise Greg Mutzi's work with Bounce Back and the biosecurity program on the Gamma Ranges National Park. And that clearly shows that rabbits declined once RHDV came in quite significantly, and there was a substantial drop in their predators to the point that on many occasions they weren't recorded at all. Most of this stuff's done either with spotlighting and track network stuff.